Alright, this is Mr. S in Naka Environmental Science, and we're getting started with Unit 8 today, the sources of pollution. So it says, waste should be viewed as a system. So in the environment and the natural system, there are inputs like soil, water, minerals, and light, and there are outputs, but they always go back into the inputs in nature. So these are all natural things that circulate through the ecosystem. Human systems include all those plus synthetic materials manufactured by humans. So those outputs are wastes, right? Waste looks very different in the natural world. Here you have, wood and debris, but is that waste? What about this? How about this? Well, waste are material or outputs from a system that are not useful or consumed. And they can't go back into the ecosystem, right? And so these are the two main points from this topic. One is that point source pollution is produced from a single identifiable location, like a smokestack, a waste discharge pipe. So you can see exactly where the pollution is coming from. That's called point source. Now, non-point source is where pollution is produced from a more diffuse, broadly defined area. So let's say we have pesticides. There's pollution from the animal feedlot, from the suburban area. There could be many different forms of pollution going in, and so it's not direct. It's a collective source of pollution rather than a very direct one. So how is it helpful to a community to identify point sources of pollution, and which type is more difficult to control and why? Think about that for a second. Well, you can try to reduce, mitigate, or penalize direct sources. It's pretty easy, right? It's pretty clear. But for non-point pollution, it's difficult to identify and control and may have many more stakeholders. Okay, and then the next topic that we would go over is the human impacts on aquatic ecosystems. So all the ways that we're really polluting the aquatic ecosystems, and this one will be a little bit longer. Here are some of the various ways to say water is life, water is sacred. As we know, a lot of our waterways have been threatened by the settler colonial influence and have to be defended. So this is the famous picture from the Dakota Access Pipeline protests. And so organisms have a range of tolerance for various pollutants. They can have an optimum range for each factor where they can maintain homeostasis, but outside of that range, organisms may experience psychological stress, limited growth, reduced reproduction, and sometimes even death. So this is kind of what you would see with a lot of species. They can survive in a certain range of these chemicals or pollutions. Alright, so these are the benefits or the importance of aquatic ecosystems and coral: biodiversity and habitat, shore protection, tourism, and a food source. So these are super important aspects that we need our environments and our oceans to survive for, right? And also medicines. If you look at coral reefs, they provide all of these things: medicine, tourism, food, biodiversity, protection. So as the corals die, a lot of the species on Earth dies, as well as the protection of the land from storms. 75% are at risk, and 10% have already died. It's one of the great threats of our time. So we're going to talk about the threats to coral reefs. And so boat damage, anchors and chains, snorkelers and divers. I've seen this firsthand, people just breaking off the coral and mishandling it. You can see here things like this. Pretty disgusting to see. People also fish using dynamite or poison. I had met some people who were doing this. And it's just really terrible. You don't know what to say to people when that's how they're fishing. Here's a comprehensive chart. So over harvesting is a huge issue, right? And it can damage the coral based on, how they're fished indiscriminately. So you can pause the video and look over this. Then there's chemical impacts. So sedimentation would be like all the river or all the oceanic earth getting moved over it so that it can't get sunlight. Oil spills will really choke out the coral species. And then plastic waste and microplastics, we're seeing this more and more. It blocks their pores and causes sickness for them. And then the rising sea temps. So we learned about this in Chasing Coral, but healthy coral requires algae to survive. It's its primary food source and makes it colorful. As it gets stressed, the algae start to abandon it. And eventually that symbiotic relationship or mutual relationship fades and you just have a skeleton, right? All right. And then sunscreens, pesticides, and metals also hurt the reefs. You get invasive species, like certain starfish, certain fish. And so here's one cool innovation. There are these robots that hunt for invasive starfish. They can scan them and kill them. And then there's also diseases, a bacterial disease, for example. So here's just one example of an oil company that was harming the reefs. And a Brazilian community who was trying to clean up the oil and go back from the fossil fuel era. Okay, so take a second and try to pause the video and write down how human activities might magnify each of these threats. Just real quick, jot them down, and then we'll go over them. Pause the video. Okay. Climate change, bigger and more frequent hurricanes. Currents changing with the temperatures. Salinity changes. Predation. Would cause aquarium pets and boat ballasts from invasive species. And then algae overgrowth from development, eutrophication. You should remember that. It's nutrients in the waterway that's causing algae. All right, so now I want you to go ahead and go to this website and play and explore some of the coral features. And then we'll pick up this topic on the next video.